Okay, in last lecture we have seen the Fourier series for the function which lies in the range -c to c, and before that 0 to 2c. Okay, now this is the last point of our chapter, that is half range series. It is the same as 0 to pi, 0 to c in that case. It is same as 0 to pi, or why it is called half range series, because in Fourier series one summation is for cos and other summation is for sine. Okay, if sine summation gets 0, we call it as half range cosine series. If cosine series gets 0, we have only sine series, sine summation. In that case, that range that series will be called half range sine series. Okay, let us see the formula and straightforward examples. Okay, half range series in 0 to c. Half means -c to c. If you consider -c to c range, then -c to c can be partitioned into exactly half by this 0. Okay, that's why it is called half range series, because in every example after this, every example the limit of lower limit or the interval or limit will start like this only, 0 to c, like 0 to 1, 0 to 2, 0 to 3, 0 to 4. Okay, 0 to pi, like this. Okay, that means half, the only half interval we are consider. That's why it is called half range series. And if it is sine is there, we call it as half range sine series. If it is cosine is there, we call it as half range cosine series. Okay, formulas are similar like above, like earlier. Now half range sine series, we have formula for Fourier series as fx is equal to summation bn sin n pi x by c. Simple. Okay, where interval is 0 to c. We have to calculate first c value. Now bn, in this case bn becomes 2 by c. It is like even an odd function only. The formulas which we have already studied for even an odd function, like that only. 0 to c fx sin n pi x by c, exactly they are same. And for half range cosine series, here half range sine series, uh, here a0 and an are 0, and half range cosine series, here bn becomes 0, like this. Okay, like even an order function. In this cosine series, a function can be written as a0. Fourier function can be written in the Fourier series form as a0 by 2 plus summation an cos n pi x by c, where a0 is given by 2 by c 0 to c fx dx, and an is given by 2 by c integration 0 to c fx cos n pi x by c. Okay, let us start with the example. Find half range Fourier cosine series for the function this fx is equal to x 0 to and our range is 0 to c, 0 to 2. Half range cosine series formulas are this. Bn is 0, no need to write Bn here 0 because it is already half range cosine series. Therefore write down this function as it is. Fourier series is given by this, and our range will be 0 to c, should be compared with 0 to 2. Therefore c value becomes 2. Okay, first step. Next step will be, this is a Fourier series formula. In this case a0 and an should be calculated. A0 is this 2 by c 0 to c, and c value is, first write down this formula. Okay, everywhere. After that put the value of c. I am directly write down this step. C value is 2 by 2 0 to 2 fx dx. Put the value of fx, that is x. Integration of x is x square by 2. Limit 0 to 2. By putting this limit we get answer for a0 is 2. Now start with an. An formula is in 2 by c fx cos n pi x by c dx. C, put the value of c 2 by 2 0 to 2 x, fx value is x, our original function, cos n pi x by 2 dx. Now again u into v rule should be applied here. U into integration of cos is sin n pi x by 2 divided by its derivative of angle should be divided. It is n pi by 2 because it is a constant. Okay, coefficient of x. Now next, minus x derivative is 1. Its integration, this bracket's integration, where n pi by 2 is a constant as it is. Sin integration is minus cos n pi x by 2 divided by n pi by 2 should be divided. Already n pi by 2 is there, that's why it should be n square pi square by 2 square, that is 4. Next term will be plus 1 derivative is 0. That's why u into v rule stops here, limit 0 to 2. Now put the value of 2. If we put for upper limit in sign, in the most of the cases for upper and lower limit, check whether sign is 0. Most of the 95% cases sign terms get 0. Only cos terms remains. Only 1 to 2 examples are there where sign is there for limits. Now if we put 2, 2 gets cancelled. Here sin n pi we know 0, and for 0 sin 0 is 0. That's why only this term we have to put the limits. Minus minus becomes plus. This is this 4 comes to the numerator, 4 upon n square pi square, cos of n pi x by 2, 0 to 2 as it is. Now put the upper limit 2 here. In x exists here only. 2 gets cancelled. Cos of n pi is minus 1 raised to n. This is a constant, take outside. Minus 1 raised to n for upper limit, and lower limit cos 0, 0 into anything is 0, cos 0 is 1. This is a n value. Therefore put the value of a naught and a n in the Fourier series. This is half range cosine series. Fx is equal to a naught by 2, 2 by 2 plus summation this a n into cos is remaining, cos of n pi x by c. C value is 2, n pi x by 2. This is the formula. This is the final answer. 4 upon pi square is a constant, take it outside. Everything is same as earlier, just only formulas are different. Next is next example. It is a homework for you. Find Fourier half range sine series. This is an example of cosine series. This is a homework for sine series. Okay, only one calculation is there for bn because a naught and an is 0 for half range sine series. Function is given by x into bracket 2 minus x. Multiply this x to the inside so that easily you can take the integration with the sign. In 0 to 2, range is 0 to 2, which we should be compare with 0 to c. C value is 2. Okay, comparing the corresponding places. Now answer for this is bn. Answer means bn value is only calculations. This is the answer. And Fourier series is written as fx is equal to summation bn sin n pi x by 2 by c. C means 2. Okay, put the value here as it is. Take this 16 by pi cube only constant outside of the summation and from 1 to infinity. Okay, now let us see. Find half range cosine series now for the function x minus 1 bracket square in the range 0 to 1. Let us start. 0 to c will be compared with 0 to 1. C value becomes 1. Now half range cosine series is given by fx is equal to a naught by 2. Same series, same formula. Call that equation number 1. Let us start with a naught. A naught is 2 by c, fx dx 0 to c. C value is 1. 2 by 1, 0 to 1. Fx is x minus 1 bracket square dx. Now this is arithmetic. X raised to n integration should be applied here. That's x minus 1 bracket cube by 3. And its derivative of this bracket should be divided. That is 1. Okay, a derivative of this bracket, simple bracket is 1. Limit 0 to 1. Now put the upper limit 1 minus 1 is 0. Upper limit is 0. Lower limit is 0. Minus 1 cube divided by 3. Now minus 1 cube is minus 1. Minus minus becomes plus 1 by 3. Answer is 2 by 9. Now a naught. These are very easy examples. an is 2 by c into 0 to c fx cos n pi x by c dx. Put the value of c. We get 2 by 1, 0 to 1, x minus 1 bracket square cos n pi x by 1 dx. Now u into v rule again. This is u, this 2 as it is, into integration of v sin n pi x by coefficient n pi minus its derivative here. Derivative of x minus 1 by square is x raised to n. Derivative should be applied first. 2 into x minus 1 into derivative of bracket is 1 multiplied. This is derivative of this into its integration. Sin n pi x integration minus cos n pi x upon n pi divided into n pi becomes n square pi square. Next term will be plus its derivative here. 2 is a constant, x derivative is 1, 1 derivative is 0. Therefore 2 into 1 is 2. and its integration minus as it is, n square pi square as it is, cos n pi integration is sin n pi x upon n pi, already n square pi square, therefore it becomes n cube pi cube. Bracket complete, limits 0 to 1. Okay, now if you put upper limit in this, 1 minus 1 becomes 0. Here also sin of n pi is again 0, both the terms for lower and upper limit. Sin 0 0 vanishes, only this terms remains, therefore it is minus minus plus 2 into this bracket into cos of n pi x upon n square pi square remains. Limit 0 to 1. Now take this 2 outside and put the limits 1. If you put 1 here, 1 minus 1 0, upper limit becomes 0 into anything is 0, minus lower limit, put the bracket 0 in x, it becomes minus 1, cos of 0 is 1 divided by n square pi square. Okay, now again minus minus plus 4 upon n square pi square is the answer for an. Therefore Fourier series is given by this: a0 by 2, a0 is 2 by n divided by 2 means 2 gets cancelled, 1 by 9 plus summation an cos n pi x by c. C value is 1. Therefore take this constant 4 by pi square outside, summation cos cos of n pi x upon c is 1 upon n square is only there. Okay, okay, finding where to find. See, in this particular example, fx is given in the interval format 0 to pi by 2 and pi by 2 to pi, means our interval becomes 0 to pi. This is lower limit, this is upper limit, 0 to pi, and 0 to pi, in between that we know this is pi by 2. Okay, function is split into 2. The question is where to show that fx is equal to this. Now in this question particular, it is not given in the example that whether we have to find out Fourier sine series or Fourier cosine series. It is directly they have proved that there is a question where to find fx in this series, and in this series if you observe, only sine terms are there, no cos term. And in our Fourier series, where sine term exists in bn, coefficient of bn, that's why this example is of half range sine series. Okay, now let us start. Now our range is 0 to pi, which is compared to 0 to c. Value of c is pi. Now half range sine series is given by this formula. Okay, now put the c value pi here, we get pi gets cancelled, only sine nx. Okay, now we have to find out bn only here. Bn is 2 by c, this is the formula for bn. Put the value of c, pi, 2 by pi 0 to pi fx sine n pi x upon pi gets cancelled, sine nx only. Okay, now put the value of function first. In 0 to pi, function is split into 2. That's why 0 to pi by 2, pi by 2 to pi. In 0 to pi by 2, this as it is, fx is x, and pi by 2 to pi, fx is pi minus x, sine x as it is. Now use u into v rule first. Put the curly bracket 2 by pi. Now square bracket for first integration. U into v rule. U into integration of sine is minus cos nx upon n. Derivative of angle. Minus x derivative is 1. This integration here. Integration of cos is sine nx upon n. Already n is there, n square. And this minus as it is constant. Next term will be 0. That's why first integration stops here, 0 to pi by 2. Now plus second integration. Put the bracket. U into integration. This sign is same. That's why these two brackets are same here. That's why brackets are very important. Now take into u is different, pi minus x, and its derivative here with minus sign, that is minus 1. Put the limit pi by 2 to pi, curly bracket complete of the whole term, because 2 by pi is multiplied to the two of them. Now simplify. Put the first pi by 2 here, pi by 2 into minus cos of n pi by 2 by n, minus minus plus sine of n pi by 2 upon n square. Upper limit complete. For lower limit it becomes 0. Sine 0 is 0. 0 into anything is 0. No need to write 0. Lower limit plus now. Now next this. put pi here, pi minus pi 0, and sine of n pi is again 0. Upper limit is 0. Now minus lower limit, put the bracket, pi by 2 here. Pi minus pi by 2 is a pi by 2. This minus as it is, minus pi by 2 cos of n pi by 2 upon this n. And this is minus minus minus, 3 times minus is 1 time minus sine of n pi by 2 lower limit upon n square. Bracket complete, square bracket complete. And this is curly bracket complete. Okay, now simplify. This minus pi by 2 cos of n pi by 2 upon n. This minus minus plus pi by 2 cos of n pi by 2 upon n gets cancelled. One is per minus and second is minus minus plus. And this one sin n pi by 2 upon n square and minus minus plus sin n pi by 2 upon n square gets add 2 times. It becomes, this is as it is, 2 times sin this term. Okay, now 2 so 4 upon pi n square sin n pi by 2. This is bn. Now put this value in the Fourier series. We get fx is equal to summation an is this, sin n pi by 2, this is as it is, and sin n pi x by c, it is already sin n x here. Okay, take this only constant 4 by pi outside irrespective of n. And x, that's it. Okay, therefore expand this just by putting 1 2 3 and so we get this, because we have to prove that series. This is the answer, and we have to calculate sin pi is minus 1. Okay, sorry, sin pi by 2 is 1, sin x upon 1 square, that is 1, plus sin pi we know it is 0, that's why we have neglected this term. Sin 3 pi by 2, if you have calculate on calculator, it becomes minus 1 upon 3 square into sin 3x, and so on. It will be like this only. Okay, if you observe this, sin x, sin 3x, sin 5x, next term will be sin 7x upon 7 square. Okay, this is the what we have to prove. Now this is the homework for you. Find half range series, sine series for this function. Function's range will be 0 to 1, and 0 to 1 is split into 0 to half, half to 1. Okay, this is bn value. Now find half range cosine series for the function fx is equal to x sin x. Is the homework. Okay, we have already seen such type of example earlier. In the limit, in the cosine series means we have to calculate only a0 and an, bn is 0. Now for Fourier series is given by this. Now if you observe this, it has two columns. It is b1, a1, because in one example we have seen where this is an. Okay, this is turns to be an. N should be not be equal to 1, n start from 2 here, and for n is equal to 1 we have to calculate b1, a1, and a1 find, it is a hint, find a1 for n is equal to 1, and that a1 becomes this term minus half and cos of 1x. Already we have seen such one example like that only you have to solve. Next, find find half range sine series for fx is equal to e raised to x. It's very easy example in the interval 0 to 1. Now fx can be by sine series. Fx is given by this, where c is 1, put the value of c is 1 here. We have to calculate bn is this. It's a very easy example. Okay, e raised to x into function value 0 to 1 sin n pi x by c. C value is 1 n pi x. Now we have already know this integration e raised to x sin e raised to x sin bx, e raised to x upon a square plus b square, a sin bx minus b cos bx. This is the integration we are using here. Already we know this example. Here a is 1 and b is n pi. This is e raised to x upon a square plus b square. A into A is 1 sine bx minus b is n pi cos of n pi x 0 to 1. Putting the value upper limit, lower limit, we get this answer. By solving this, we know this, it becomes this, and final answer is this. Taking n pi common only, you get this answer. Okay, therefore final answer for Fourier sine series is given by this summation. This is bn and this is sin nx. Take 2 pi only common outside, a constant outside the summation. Fx value is e raised to x. This is a Fourier sine series, half range Fourier sine series, or it can be written as only Fourier sine series, Fourier cosine series. Instead of Fourier half range, they just eliminate the half word. Okay, Fourier sine series, Fourier cosine series means Fourier half range cosine series, half range sine series. Okay.